Let's solve few problems based on whatever we have learned so far. Okay, look at this one. Find the second order derivatives of these many questions. Okay, first is a very simple one. In the next one, we'll do the proving sums. All right. See the first one, x cos x, right? So here, let y is equal to x cos x. Now y dash. Remember, use the product rule. So this is going to become cos x minus x sin x. Correct? Now y double dash, that means you are going to differentiate this function, right? Cos x is going to become minus sin x minus of, here you have to apply the product rule. So here you have to apply product rule, isn't it? Because it's a product of two expression, or you can say product of two functions, whatever. So when you have x into sin x, again, if you apply, you're going to have sin x plus x cos x, correct? So y double dash minus sin x minus 2 sin x minus x cos x, or you can say minus of the whole thing. I mean, whichever works. All right, both of them are correct anyway. So this, or you can say minus of this. This is going to be the final answer. So this is the answer for the first one. Now let's do the second one. See the second one, y is equal to x cube log of x. Again, product rule as well as chain rule, both you need to apply here, right? So first y dash is going to become 3x square into log x plus x cube into 1 by x, which you can make it as a square, correct? Now y double dash, this is going to be 3 times, here you have to apply the product rule, correct? Product rule of this is going to become 2x into log x plus x square into 1 by x, right? Plus here we have x square, correct? X square derivative becomes 2x. Here cancel off these two, multiply. So y double dash 6x into log x plus 3 into x is 3x plus 2x, correct? Or y double dash is 6x log x plus 5x. This is going to be the answer for the second question. Fair enough? Now let's do the third one. See the third one. So y is equal to e power 6x into cos 3x. It is very similar to the previous one, the second one, because you are applying both chain rule as well as the product rule. Alright? So pay attention and then do it. Y dash, first 6 e power 6x into cos 3x, right? Minus e to the power of 6x into 3 sine 3x. Now you can further simplify this. That means you can take 3 e power 6x as common. So if you take this as common, you'll get 2 cos 3x minus sine 3x. See, this is going to be y dash value, correct? Now once you have y dash, again differentiate. But remember, when you're differentiating here, this is your first function and this entire thing is your second function. Okay, so keep that in mind. So y double dash, this is going to become 3 into e power 6x, you have to differentiate, right? So which is going to become 18 e power 6x into 2 cos 3x minus sine 3x, this plus 3 e power 6x into minus 6 sine 3x minus 3 cos 3x. Correct? Now we need to do a lot of simplification because we have e power 6x, 18, 3, that, this and all. We need to do a little bit of simplification. Alright, so let's do the simplifying part. Now, after these kind of, see, most of the proving sums also, you are going to have the trigonometric function with an exponential function. In all those cases, you do have to simplify. Fair enough? So, let's do this one now. What do you have? Y double dash is equal to. Now, if you multiply the first two terms, so when I say the first two terms, we'll multiply this and this first and this one. So that you know the cos 3x part, we are going to take it together. Alright. So here 18 into 2, 36 e power 6x into cos 3x. Then here minus 9 e to the power of 6x into cos 3x. Correct? Then after that, we'll take this one and this one and this one. Right? So when you're doing that, you'll get minus 18 e power 6x into sine 3x minus 18 e power 6x into sine 3x. Correct? So now 36 minus 9, 27 e power 6x into cos 3x minus 36 e power 6x into sine 3x. You can take common. So that is, you can take 9 e power 6x as common into 3 cos 3x minus 4 sine 3x. So this is going to be your final result, or you can say this is the final answer. Fair enough? So this is the answer for the third question. Fair enough? Now let's do the fourth one. See the fourth one, what we have, y is equal to log of log x. Correct? Here it's just a chain rule. You have two functions, one within the other. You have to differentiate. Alright? So y dash is equal to 1 by log x into 1 by x. Correct? Or we can write this as 1 by x log x. Fair enough? Now y double dash. See for the y double dash part, you can use the function that is the quotient rule you can apply, u by v form, where u is 1. So u is going to be a constant. You can use that, or you can do it like x into log x to the power of minus 1, and you can do it. Both of them are going to give you the same answer. It's not going to be different at all. Alright, since it's in the division part, I'm going to use the quotient rule. Alright, that means the first function is u, second function is v. So u dash into v. So u dash is 0. 0 into v is 0 minus 1 into the product rule. So this is going to become log x plus x into 1 by x divided by x log x whole square. X and x cancels, right? So what do you get? Y double dash is equal to minus of 1 plus log x divided by x log x whole square. This is going to be the answer for the next one, that is the fourth one. Clear? Let's do the fifth and the sixth. So two more questions are there. We'll finish the fifth and sixth now. All right. See the fifth one, what we have, y is equal to sine of log x. All right. Chain rule. Y dash becomes cos of log x into 1 by x. So we can write this as divided by x. Now, when you are calculating y double dash, we have to use the quotient rule, correct? So y double dash becomes the whole thing divided by x square we have. So first, the derivative of the numerator minus sine of log x into 1 by x. This is just u dash, correct? Multiply this by v minus cos of log x into 1, because the derivative of v, that is the denominator, is 1. X and x cancels. So what do you get? Y double dash is equal to minus sine of or minus of sine of log x plus cos of log x whole divided by x square. This is the answer for this one, the fifth question. Fair enough? Let's do the sixth one now. See the sixth one, y is equal to tan inverse x, correct? So y dash 1 by 1 plus x square, isn't it? Now what you can do, you can write this as 1 plus x square whole power minus 1, correct? Now we can apply the normal x power n type of formula. So y double dash becomes minus of 1 plus x square whole power minus 2 into 0 plus 2x. Derivative of 1 is 0, right? Or in other words, you can say y double dash minus 2x by 1 plus x square whole square. Clear? So these are the type of problems whatever we have done so far. So these are problems where you calculate this higher, that is the second order derivative. Alright. Now in the next video, you will see the proving sums. So you are going to have a function y and I'll ask you prove that this is equal to this. Fine. So those kind of problems we'll see from the next video onwards.